Problem 5, we're taking a look at always, sometimes, or never true. So for the first couple problems here, problems A and B, I'm just going to go through and solve. So the first thing for problem A, I'm going to distribute the negative. I'm going to end up getting 3x minus 2 minus 4x minus 4 equals negative x minus 6. Clean this up here by combining like terms, so I get a negative x minus 6 equals a negative x minus 6. At this point, you may notice they are both the same thing. If you continue solving, I would add x to both sides, and they cancel out. Negative 6 equals negative 6. And if you kept going, you could get 0 equals 0, but nonetheless, at one of these steps, you're going to say they're the exact same thing. If they're the exact same thing, they are always going to be equal. Negative 6 will always equal negative 6. 0 always equals 0, which means these are always true for any value of x. So looking at problem B now, I'm going to do basically the same thing. So I have 3x minus 5. I'm going to distribute the 2. 2x plus 2 plus x. So I'm going to combine like terms on the right side to give me 3x plus 2. Now when I get my x's, I cancel those out. I would subtract them from both sides. I now have negative 5 equals 2. That never works out. Negative 5 never equals 2. So this one is never true. All right, now problem C and D, we start taking a look at some different situations here. Sign graph for problem C, if we think of our standard sign graph, I start off at 0, 0. I go up to 1, I go back to 0, down to negative 1, back to 0. That is the graph of sine. But now I want to make sense of this second graph, cosine of pi over 2 minus x. And how I'm going to take a look at that is I'm going to look at my unit circle and then talk about the graph as well. So when I input an x value of 0, so when along my x-axis here, when x is 0 is right here. When I input 0 into this, I end up getting cosine of pi over 2. The value for cosine of pi over 2 on my unit circle, that's pi over 2. The cosine value for that is 0, so I end up getting an output of 0. So when I input 0, my output is also 0. The next thing I look at here is I'm going to look at an input of pi over 2. So when I put pi over 2 right here, I end up getting cosine of 0, because pi over 2 minus pi over 2 is 0. On the unit circle, that is 0 radians right there. And my cosine value is going to be 1. My distance here is 1. So for an input of pi over 2, my output is 1. I am going to continue that. I'm going to input pi. So if I put pi right here, I'm going to end up getting cosine of a negative pi over 2. Negative pi over 2 on my unit circle is right here. That is a cosine value, again, of 0, because my horizontal change is 0 on that one. If you notice what's happening as I look at the unit circle, is we started here, and now I'm going backwards around the unit circle. And the reason why I'm going backwards around the unit circle is because I'm subtracting x. So when I input 3 pi over 2, I'm going to rotate again to this spot. That is a cosine value of negative 1, so my output is negative 1. And when I go and I put in another value here, when I input 2 pi, I'm going to be back at this spot, which is now 0. So that is the graph of cosine of pi over 2 minus x, which is the exact same as sine of x. So I could look at my equation here and essentially say this can get replaced with sine of x. So sine of x equals sine of x. That is always true. So my last problem then, tangent of x equals 1. I'm going to again think of my unit circle. Tangent is the ratio of sine over cosine. So when I want to think when does that equal 1, that only happens when sine and cosine are the same lengths. So what triangle in my unit circle gives the same lengths for sine and cosine? Remember, sine is that side, cosine is that side. That would end up being a 45, 45, 90, or pi over 4. So pi over 4 radians gives that one. The other possibility that I have is in quadrant 3, because now I have a negative square root of 2 over 2. And a negative square root of 2 over 2. So when sine is a negative square root of 2 over 2 and cosine is a negative square root of 2 over 2, I once again have a positive tangent value. That gives me 5 pi over 4. So my solutions to this one are when x equals pi over 4 and 5 pi over 4. At this point, we also could talk about going around the unit circle a few more times, but that's in a different lesson or later in this lesson. So for right now, we're just going to go with these two solutions on one time around the unit circle.